So welcome to 9.8. So we're going to do multiplying and dividing of scientific notation, but there's a detail that we didn't go over, and we have to do that today. So we're going to multiply scientific notation. Remember, let's just remind ourselves that, say this number, first one, you have 5, say you had 5y to the 7th times 1.3y squared. You would do 1.3 times 5, which is 15. 6.5, and then you would add the exponents. So it would be 6.5y to the 9th. Here, 5 times 1.3 is 6.5. You do times 10 to the 9th. It's the same rules. 3.3 times 3 is, I think, 9.9. We still add the exponents, negative 2 plus negative 5 times 10 to the negative 7th, and you're allowed negative exponents in scientific notation. Now, this one is 3.4 times 3. 3 times 4 is 12, 3 times 3 is 9, is 10, all right? So let me just clean this up a little bit of these other things I wrote. And so we have 10.2 and times 10 to the 5th. So what's wrong with that? Why is that not the right answer? Well, it's not the right answer because it's not in scientific notation. Turns out the right answer has to start with 1.02, right? Because scientific notation starts with 1 through 9. So whenever this happens, you have to fix it. So we need something that equals that starts with 1.02. Well, realize that I just moved the decimal point over, and I divided that by 10. I made it 10 smaller, all right? Well, if I made that 10 smaller, I need to make this 10 bigger, which is 1 bigger, right? Because I make that 10 to the 6th, and now I've made it 10 bigger. I've balanced it out. And so the correct answer is 1.02 times 10 to the 6th. And that's the part you just saw we're going to add today, right? So if you get 12 times 10 to the 9th, that's the same as 1.2 times 10 to the 10th. If you make this one smaller, you make by 1. You make this one, if you make this one smaller, then this one has to get bigger to compensate, to balance it out. We'll also show this one. If you have 1/4, right, well, you don't leave it 1/4, you make it 0.25. You're not allowed to have 0.25. So this time, if you make it bigger, right, we're multiplying it by 10, you make this one smaller to balance it out and have something that's equal to it. I really just taught you the lesson, but we're going to go over all that again. All right, so we're going to rewrite this as an equivalent amount. Sorry, 12.5 times 10 to the 3rd is the same as 1.25 times 10 to the 4th, right? Because that got smaller, so this has got to get bigger. 16 times 10 to the 2nd is the same as 1.6 times 10 cubed. 134 times 10 is 1.34. Now, we move the decimal point once in the other, right, in the other ones. We moved the decimal once, so we made it up by 10. But now we're moving the decimal twice, so what do you think happens here? This goes up by 2, right, because 10 squared is 100, right? When you move the decimal twice, you're either multiplying or dividing by 100. So we're going to make this 2.36. Now notice, all right, we've got to make this one bigger, right? Because we're making this smaller. So what's 1 bigger than that? 10 to the negative 3rd. All right, so this is 1.8 times we made this smaller, we have to make this bigger, negative 2nd. All right, again, we're moving it twice. We're making this. All right, so this time we're making 708 into 7.08, so we're adding 2 to this, and it's times 10 to the negative 3rd. Right, you move it once, you add 1. You move it twice, you add 2 to make it equivalent. All right, so let's do a little work here. 2 times 7 is 14. You're not allowed to leave 14 times 10 to the 5th. You write 1.4 times 10 to the 6th. Right, 2 times 8.03 is 16.06. Add the exponents times 10 to the fourth. We're not allowed to leave that. It's 1.606 times 10, and we've made this smaller, so we make that bigger, 10 to the fifth. 9 times 2.1, 18.9. Add the exponents times 10 to the negative sixth. Not allowed. Has to make it 1.89. We've made this smaller. We have to make this one bigger, times 10 to the negative fifth. 20 times 9, 180 times 10 to the negative sixth. Well, we have to have 1.8. That means we move the decimal twice. So that means we're adding 2 there, times 10 to the negative fourth. Right? A scientist weighed 12 grams of sand with an average weight of 1.5 times 10 to the negative. Find the total weight. The total weight is 12 times 1.5 times 10 to the negative second. So 1.5 times 12, 10, 3, stepping over. So move it over. So we get 18 times 10 to the negative second. Not allowed. 1.8. We got to add 1 times 10 to the negative first grams, which is also 0.18 grams, right? Negative at 1, you would just move it over once. But it said write your answer in scientific notation. All right, so now all those, the answer was more than, right? It was 10 or more. Now it's going to be less than 1. And we have to make, right? It has to start with 1 through 9. So it has to be 5.3. Now we're going to subtract 1 from there. This has to be 6 times 10 cubed. Now we have to move it twice. So this is 5.9, and we have to subtract 2 to here. So 5.9 times 10 to the third. This is 2 times 10. Now we have to subtract 1, so 10 to the negative fifth. This is 1.6. We have to subtract 1 times 10 to the negative fourth, right? When you make it bigger, you make this smaller. We have to move this twice and get 7.41. So we have to move it down by 2, 10 to the negative fifth. All right, so now let's put this together. 1.2 divided by 4 is 0.3, right? So we get 0.3 times 10 to the seventh, canceling. And we get 3 times 10 to the sixth. 4/5, right, is 8/10, which is 0.8, or you could do 4 divided by 5, 0.8. And then 6 minus 9 is negative 3. So we need 8 times 10. We got to, right? So this is bigger, so we got to make this smaller by 1, 10 to the negative fourth. 8 times 10 to the negative fourth. All right, 2.8, 28 divided by 4 is 7. So 2.8 divided by 4 is 0.7. And then, oh, this is negative 7 minus negative 5. Be careful of that. Negative 7 plus 5, negative 2. So 10 to the negative 2. So we have to make it 7 times 10 to the negative third power. That bigger, that smaller by 1. 3/4, right? 3/4 is 75 hundredths, right? Which is 0.75. So 0.75 times 10 to the 0, right? That's it in scientific notation, but that is 0.75. But in scientific notation, that's what it would be. All right, how many times larger is, all right, so this, whenever you see this times larger business, this is a division problem. And you put the bigger number up top, the one with the bigger exponent, and the smaller number on the bottom, right? It's like, if I said how many times larger is 12 than 3, you'd say 4 times, 12 divided by 3. Same thing here, right? How many times larger is 1,000 over 100? Well, it's 10 times larger. So here we have 1.2 times 10 to the 7th over 3 times 10 to the 5th. Well, 12 divided by 3 is 4, so this is 0.4 times 10 squared, right? You're not allowed to leave it that way, so we're going to make it 4 times 10 to the first. Well, that's 40, right? It doesn't say scientific notation, so either would be good. It's 40 times larger. The bigger one goes up top, so that's 4.5 times 10 to the negative third over 9 times 10 to the negative fifth. 9 goes into 45, so this is 0.5. Now, negative 3 minus negative 5 is negative 3 plus 5, or a 2, times 10 squared. So this is 5 times 10 to the first, or 50. It's 50 times larger. All right, so let's practice all this. So this one is, right, 8.1 times 2 is 16.2. Add the exponents, 10 to the negative fifth. Not allowed to leave it that way. 1.62. Now they're going to be mixed together. So we made that smaller. So we're going to go up by 1 and make that, right, this guy has to be bigger to balance it out. 21 divided by 7 is 3, so this is 0.3 times 10. Negative 8 minus negative 3 is negative 8 plus 3 times 10 to the negative fifth, right? Which equals 3. So we're making this bigger. So this has got to get smaller by 1. 10 to the negative sixth. A little neat there. 6 times 25 is 150. So this is 150 times 10 to the fifth. Well, we need that to be 1.5. So we're moving a decimal twice here, making it smaller. So we have to make this bigger, times 10 to the seventh, right? We move it twice, we add 2 or subtract 2. So this is division. 18 is bigger than 16. So this is 0.6 times 10 to the second, which is the same as 6 times 10 to the first, which is 60. Okay, good luck with the homework.